Hi, my name is Dave Whyte. It's really great for taking part in this Cloud Native Virtual Summit. I really hope you like the session and you're able to take a few things away from it. As this is a virtual summit, I thought it was really important to try and do something different and make a human connection at the start of the session. So for the next 30 seconds, I want to tell you a bit about myself. I want to keep this video on. I promise you, as soon as this bit's done, it's turned off and it's going back to the rest of the presentation. So briefly, I'm an ops lead at Autotrader. I've been an Autotrader for around 15 years and been in various operation roles, mainly roles focused around the uptime, stability, and performance of our website. I'm also one of the co-organisers of the DevOps meetups in Manchester. And that's it, short and sweet. So let's crack on with the rest of the presentation. I've called this talk Under the Bonnet at Autotrader. Just to give some context, we're currently migrating all our applications to the public cloud with the aim of turning off our data centers by the end of the year. Along the way, we built out some, I believe, truly game-changing DevOps tooling, utilizing Kubernetes and Istio. Autotrader is UK's largest digital automotive marketplace. We are a 45-year-old company. We used to be a magazine company and magazine-only company. In 2013, we transitioned from a publishing company to being 100% digital. Just so you are aware, we don't have any connection to Autotrader in America or Canada. It's pretty much a UK-only business. This is some stats from January. So there's 58 million cross-platform visits, 259 million advert views, and 14 million devices with our app on them. Underpinning all this, with 800 employees, we've got a headquarters in Manchester, we've got an office in London and an office in Dublin, around 200 developers, and 20 infrastructure and platform squad members. That's a multidisciplinary squad, a really important squad who looks after our centralized platform. This graph shows the rate of releases to our live environment. Our financial year is from April to April. We start off with manual deployments. This is 2 ops engineers, a cab, and a very frustrating release process to manage. We then moved on to auto deployments. This was more scripted deployments. Again, a burden on ops and still quite frustrating to manage. Lastly, we've moved on to still in this era now as a continuous delivery. At this point, we built out our own private cloud platform. We had to make changes to make our apps cloud native before we moved them across to the platform. The bonus around this was ops handed the release keys over to our devs. The cab process was dropped and product squads could release their apps whenever they wanted, which is really good. We moved our first app into the public cloud in December 2018, and now some apps are getting released to live multiple times a day, hence a massive jump in stats. One big benefit of this is fast feedback loops if issues are spotted and fixes are rolled out really quickly. So talking about the platform, so I'm focused on our delivery platform. It's worth being aware that we also have a separate enterprise and a data platform, and they're also in the public cloud. To give some history on our journey, we currently have 2 data centers. Along the way, we've moved from just using physical servers, then moved on to VMware, and then we built out our own private cloud on CloudStack to try and improve our developer velocity. Whilst we were running on our private cloud, we didn't really appreciate, or what we didn't appreciate was the complexity and the operational overhead of managing this. We chose an open source product called CloudStack, and increasingly there was less community support. We had challenges when upgrading and issues managing dependencies. What brought us to the fore for us was that we tried to address a GDPR concern from a customer. They wanted end-to-end encryption, and we estimated it would take about 6 weeks for us to build out a solution for it. However, 3 months later, little progress had been made. So we spiked out a solution in public cloud and achieved results within a few days. This highlighted the opportunity for us to go faster in the public cloud, staying true to our aim to increase developer velocity. In August 2018, we had agreement to push forward with a public cloud migration. We migrated the first application in December. As part of migration, we agreed that it wouldn't just be a lift and shift exercise. We wanted to embrace all the benefits of the public cloud and build out our DevOps capabilities. We also committed to moving everything, so 100% cloud migration. We built out a centralized platform supported by our platform squad on the Google Kubernetes engine and are using Istio as a platform, which helps us connect, manage, secure, and observe microservices. We want to showcase. Before I go on, it's worth discussing a few caveats. So firstly is some of the tooling that we're showing has been developed in-house. Unfortunately, it's quite entwined in our systems. We can't really open source it, but should get some inspiration around what is possible. Secondly, every company is different. So what might work for us works because we've built it a certain way, or it's a culture or process that we use that might not be compatible with you and your company. So it's worth bearing that in mind. So set my scene. So I'm going to take you through getting a basic app. I've created a basic app, and how do I check it in Docker, test it in Docker, and then how do I get that onto a platform. Also, once it is in a platform, what tools can I use from a developer point of view to make sure things look good. And then I'm going to walk through our DevOps portal. So very much a portal that a developer or operations can use to get a lot of really good information. I'll then take you through fault injection. So quite a recent thing that we've created, and started doing some chaos testing. Basically, you can inject a fault and you can see the output from that. So I'll go through a test scenario. And lastly, chaos cracking. So chaos cracking is a tool we have managed to open source, and I'll go through that at the end. So let's make a start. So I'm going to take a base application I've created, which I've called Cloud Native, and this is in GitHub Enterprise. And I'm going to do what's necessary to get this onto our cloud platform. Other tools I'm using is VS Code. Here's the application of VS Code and command line. So first step is to really get the files that I need to simplify this for developers, because it can be quite hard to configure various YAML files and Docker files. We built out an application we call Shipper CLI. Effectively, you can download Shipper CLI, install it, and that gives you a tool set you can use to talk to the platform. Let's do that. I'm going to type Shipper, this is tab complete, project init. I'm going to ask a series of questions and we need to answer. So first one is what language the app's going to be in, or is in, written, and that's in Ruby. The second name is what's the name of your project. So I'm going to keep it simple, keep that as a cloud native. Give a short description of your project. This will be shown in the app directory. I'm going to go through the app directory a little bit later. So basically I'm going to put cloud native showcase. Which squad owns this project? So I'm part of the operations squad. I'm going to put operations. Which email address should be the primary contact for this project? So we've got a concept of having an owner for an application, and we have that for ownership around you build it, you own it, you get alerts for it, you support it. Pretty much that's what we're doing. So I'm going to be the owner for this application. Next one is who is the OE squad buddy for this application. So the OE is an operations engineer, and effectively we've only got a few operation engineers, and we split it up so they're sort of the ops sort of contact for the product squad. So if a product squad's got an issue, they'll contact the OE squad buddy to help them. Likewise, if we need to speak to a product squad about their application, if it's not performing, then normally we'll get the relevant OE squad buddy to go and speak to him about that. I'm going to pick the first one. So Dylan, what environments would you like to deploy to? So I'm only going to deploy this to pre-prod just to save time. So I won't select prod. By default, we don't really select dev because dev is you doing your test within Docker. So I'm going to keep that as just pre-prod. That's been created a series of files. So it's created a Docker file, Docker compose, various Helm files, and the a README from a template that we got basically. And if I was to ls, I can see what's created these files. So going across to VS Code, I can see these new files here. So my first step is I want to, before I can put this on the platform, I want to test it locally within Docker. I know that I've got a few small changes to make to this Docker file. So this is a notepad that I've got with these changes, just very small adjustments. Just to add this command at the bottom, I'll save that. And I need to overwrite this command within Docker compose and save and come out of that. So I made two small tweaks to these Docker files. And you see though, format wise, it's pretty good to have a template and me not trying to create this myself. It has pre-populated a lot of information. So if I go back to command line and do Docker compose up build, building app. That's app built. Let's go through browser and check and make sure it's working. Localhost 4567, and here's the app. This is it app wise. I've copied this from the delivery platform docs, which you'll see a bit later. Quite like the flashing unicorns, but this is the app working, so it works locally within Docker. So I'm going to cancel that and show that's cancelled. That's the Docker part. I'm actually going to clear the screen. Make it simple to follow what I'm doing. So from the VS Code, I'm going to look at the Helm files. So I've got the pre-prod and a values YAML. Click on the values YAML. You can see here there's a lot of really great information. So at the bottom, I've got the network policies. So it might be that I want my app to talk into another app. As is microservices, we pretty much put the network rules in within the values YAML files. So my app doesn't need to talk to another app, and no other apps need to talk to my app. So I'm going to keep this simple as cloud native. This section, so you can see why now I was answering these questions. It was creating basically the service discovery, and this come into play a little bit later when I show you the application dashboard. Then we got the resources. So templates of resources. If I want to, I could change these. For this app, it's not going to be touching the sides. Then we've got the readiness probe. So I've got to make one slight adjustment because it's a basic app. I haven't got health check endpoint. I'm going to change this to 4, 5, 6, 7. And I'm going to change slightly up here the H2 port to be 4, 5, 6, 7. And all of the details I'm going to leave alone. So I'm going to save that. So only a couple of changes for all these files. But what I do need to do is get this into my Git repo. So I'm just going to do git add and git commit. I'm just going to put ready for cloud. And git push. Cool. So I go to my repo, you can see all the new files in there, including the README. I'm not going to change any of this README, but we quite like the template, which you can adjust if you want. So next thing, I need to be getting this pushed into GoCD and then push it onto the platform. So to do that, I'm going to go back to using our trusty shipper and clear the screen. I'm going to do shipper project create. So what do I want a pipeline to be called? I'm happy with shipper-cli .cloud native. What group should pipeline be created in? So we've got various groups within GoCD. I'm part of the operations engineering. What's the URL? The URL for your app's Git repo. It's already pre-populated, which looks good. And what environments would you like to deploy to? So I'm only going to select, as previously stated, to the pre-prod. So keep it at that. Please enter your GoCD username. So it's first name, last, and password. It's always good when that works without any issues. So pipeline successfully created. Please review its configuration. I'm just going to click through to that, and this is the pipeline. So to start this off and push it out, I'm just going to trigger it. So I'm going to use shipper pipeline trigger. What's the name of the project? Username and password. Cool, it's triggered. So first stage is publish, the second stage is to push it to the environment. I'm just going to follow what it's doing. So picked up an agent. Take a few seconds to go through this. So checking for dependencies, and it's building the application. First stage done. Refresh. So now it's getting pushed out to pre-prod. It's waiting to pick up an agent, so it's picked up an agent. And it's starting to build. So validating project for pre-prod. It's going to go through a series of validation checks. If it fails any of these checks, then it's going to error. So it's gone through those checks, checking network policies, making sure the YAML validation and other aspects. So it's past that. Next stage then is it's doing all what's needed behind the scenes to be creating various policies, various networking, various istio configs, etc. It takes a little while for it to churn through that. I'm not. Well, it's worth noting that I've not pushed this app through for, so this is creating it all from scratch. Not pre-done this app. So give it a few seconds to go through and configure what's needed. And that's now completed. So just to see, again, the Go agent checking dependencies, validation check, and adding all the relevant components and all the relevant policies. That's passed, that's good. So if I go back to command line, I can go back to shipper again. So I've deployed, I want to get the status of that deployment. So if I do shipper project status environment pre-prod, that's going to go away and talk to your platform and bring back various information. So that's brought back again the service discovery stuff, some information I've put in, the relevant URLs, importantly URL for the application itself, and then metrics. So if I click on this app one, this is the app up and working, so that's good. I'm glad that worked. I can come away from that. What about some other stuff? So I could go to logs, I can go to the tracing. There's not going to be much tracing there. There's a few items. Probably find that's the just readiness probe check-in. But basically some traces in place. So I can also check the logs. So if I just do shipper logs eprod, this is going to go away and get the logs from the pods. As you can see there, me testing, but also this is the readiness probe that's checking the URL. So the main point trying to get across here is, as a developer utilizing Shipper CLI, I can connect to a platform without the need of going to the pods directly, without needing to be understanding or installing anything different around Kubernetes. This is just the interface into platform, dragging out really essential information and links all in one place. That's it. So next I'm going to walk through our platform dashboard. Just before I do that, just thought it'd be good to summarize where we're up to. So just taking you through and showing you how easy it is to get a simple application onto the new platform. That's utilizing Shipper CLI to download the relevant templates, also using it to create the pipeline within our CI/CD tool, and how to trigger a pipeline and to get it pushed out onto a platform. Also showing you how we can use Shipper CLI to interact with the platform and drag back some essential information with checking the status. And within that, there was various links that a developer can use easily and quickly to be checking the status of their app. Now, we don't really expect everyone to be downloading all the repos and utilizing or interrogating a platform that way. We needed some other easy way of doing that. This is where the platform dashboard was born. So I class this as essentially Autotrader's DevOps portal. Any developer, any operation person, pretty much anyone really, with the access given can access this portal, and there's a wealth of information. To start off with, this is the main view. This is the home page of the dashboard. It's done by cluster, so if I click on here, you can see the environments. It's got dev, pre-prod, prod, and BCP, and all the dashboards for each cluster is pretty much laid out the same. I can tell I'm in prod currently by the top right hand corner. Just for summaries, this is dragging information from Istio, it's dragging information from Kubernetes, and also from Prometheus. I can see how many applications that I've got in live. So 335 there in total, one new this week. How many deployments were carried out in the last 24 hours. If I click through that, this takes us to Lighthouse. Effectively, Lighthouse is showing us, well, when you roll out an application, you're going through a pipeline, and the pipeline sends a signal to Lighthouse, and Lighthouse records what's been released, how long it's taken. So just for example here, this little auction elastic consumer release started at 11:56, and it took 1 minute and 5 seconds to deploy the last part of deployment. So this is a very place we can go to visually see what's released when we're releasing a lot of information, or doing a lot of releases. This is another in-house developed tool. Come back to a dashboard. I can see the distribution of applications by squad. I can see the spend by squad. So from that, I can see how much the application's actually costing the company. A whole lot of details are down here by the amount of containers, the amount of resource, so CPU, memory, and the language distribution. So we're pretty much a Java house, very clear from this graph that we are. So that's pretty much the dashboard. On left here you can see there's more areas to dig into. So next area I'm going to take a look at is the app directory. So in a nutshell, the application directory is a directory of applications that are on our delivery platform. I'm going to drill into this now to find an app and go through this in a bit more detail. So if I look for API Gateway, there's two applications. I'm going to focus on this one here. So just go through in slow time. The name of the app is API Gateway. It's looked after by the stock and search platform. So that's a product squad who is responsible for this application. The owner is Chris Kelly. It's very important to have an owner and clear ownership of an application. If Chris, say, left the company tomorrow, there's a background check that checks for AD and notes that his email address won't exist when he's removed, and we'll get an alert telling us that this app has no longer an owner. So then we'll have to make sure that we get a new owner for the application. This is a tier 2 app. So we've got 3 tiers, tier 1, tier 2, tier 3. Tier 2 means that basically there's all the normal monitoring in place, and any big system impacting issues get an email alert gets sent to the on-call engineer. A tier 1, difference between tier 1 and tier 2 is that it's around BCP. Effectively, our environment is split into 3 zones. If all of those are wiped out, we can fail over to another region. So basically, region failover. For this application, we don't believe we'll need that, so this is why it's a tier 2 app. The buddy, so buddy is what we call an OE buddy, so operations engineer buddy. Effectively, Dylan, who's an operations person, sits within the infrastructure and platform squad and makes sure that he keeps in touch with the stock and search platform. So basically keeps that connection with them. He might go to the stand-ups. They might have him as a first point of contact if they want to speak to anyone in operations about anything. And down here we've got a description. So this is a description of this application. On the right hand side you can see by this tag that it uses a DB, which is MySQL database, and the app's written in Java. There's also a drop down here. Just drop down, you've got the various URLs for the application, which is really handy. And you've got direct links to the pipeline, direct links to the value stream metric, and the source code in Git, and tracing and logs. So if I clicked on here, it'll take me through to a tracing. It takes a couple of seconds to load. This would be for all tracing for the application. So when I want to be investigating any issues, I can select one of these, and I've got a whole lot of detail about how it's going through and its interaction within the platform. I can also click through to logs, so we use Kibana. Logs are put onto Elastic, so with one click I can go through and see the logs. We don't restrict access to the logs for anyone. Anyone that wants to see the logs has got access. And working our way down, we got various metrics. So service mesh metrics, which I'll go into a bit more detail. Effectively, this utilizing a lot of the Istio data. Then metrics for JVM. So we clearly look into any issues around Java memory. And the last one I got is metrics around the database. So in database issues, I can dig in, try to have visibility of this. So that's here. If I want to, I can click through. So I click through to the application itself. There is a warning that there's an error that I'm sure being investigated. Again, description, contacts, a bit more detail about the tier 2. And right side we've got dependency graph. So this pretty much shows any applications that have got a clear dependency with this API gateway. We've got links, so effectively this is all the links that you were seeing before at a more top level. An important area is here is network rules. So because you can stipulate the network rules within the Helm files, then this drags this out. You can see this visually. So I've got the inbound network rules and the outbound network rules. This one's quite good to see. Effectively what's happening here is this app is configured to it's got an outbound rule allowing it to talk to search 1. If I click on search 1 and go to the application, I'm pretty sure you're going to see that there's no inbound rule for this API gateway on that app. So if you're trying to investigate an issue where it might be around network rules, it's quite good that we get a warning here so we can dig into it quite quickly. It's quite visual. It enables you to dig into the issue or identify the issue quite quickly. I can also leave a note here. So it might be ignore alerts on this test for now, or on this application. So ignore, just an example. I can leave a note. If it's no longer relevant, I can delete that note, which is quite handy. That's effectively the application directory. Next, we'll move on to the dependency graph. So I really love this graph. I think it's quite cool. It's quite a good way of visualizing the environment. I think before digging into this, it's probably worth us explaining how we used to do things. So I've got an old photo here. And this is the way we used to do dependency graph. So pretty much any wall we've got at Autotrader you can write on. So if you've got something to show or something to go through, you can write on the walls, which is quite good because it enables us to then draw out the network, we'll draw out the application connection dependency diagrams within the wall. So you can see here there's various names and various lines connecting all the apps. Clearly, this is, whilst it's okay, it's quite good to visualize. Obviously, as soon as an application is either decommissioned or a new app comes along, you've got to try to fit it in, and it's always a nightmare trying to keep this updated. Essentially, the last time you draw on it, as soon as the pen comes away, it's already outdated. But it worked for us, and that's where we used to do the dependency graph. Moving into this, it's just completely different way of looking at things. Main thing here as well is that this is a live, this can't go out of date. If the application is live on the platform, then this is the connections of that. And you can drill in. So I want to see what's connecting to Kafka. Click on Kafka, I can see all the connection points. So that's the dependency graph. Next, move on to the service mesh. So this link takes you through to our main service mesh dashboard. This essentially, I think, the most important dashboard that we've got, and gives you an overall health of our platform, taking on board the data captured from Istio. There's quite a lot of information going here, but we'll go through and explain or break down some of it down. So it's currently seeing prod. I can see it's prod because by the URL. We've got prod. I can change that to dev or pre-prod. Various data around cost, around the data rate in, out, success rate, etc. Then you've got the total request volume by response code. So that's good because mostly 200s, but I can drill down and see that we have got some 500s. Take that off. And these blue lines indicate deployments. So if I highlight over that, I can see various deployments, which is really important because if I've got a blue line here and afterwards we start to see some issues, then we can relate that to deployment. On the right, you've got the top 10 applications by request volume. You start to pick up on the patterns of volume. If you see some increase and decreases, it could indicate that there's an issue. The most important boxes are down here. So we've decided for now that we believe the 500 errors are really ones that we want to to visualize and be aware if there's actually any issues. So this is capturing any 500 and 501 errors. You can see here that there is some errors, but quite low level, and you got a breakdown of the actual applications are erroring. Again, the blue lines deployment are across all these graphs. So if there was, say, a blue line deployment, say if this Sauron search service, Sauron service search, and this was Sauron service search, it could indicate that there's an issue around the release. But it's a good way to visualize and clearly see if anything breaks. So if a release goes in and all of a sudden we get a massive amount of errors, then I can quickly identify it's probably related to that release. I'm going to break it down for gateway errors, and timeout, so 504s, etc. So this is a dashboard that's on various monitors, and it's just glanced at that during a day. So you do pick up an incident zone really quickly. So I can pick up an issue by visualizing it and start investigating it well before some of our traditional monitoring, or well before any customers phone in about an issue. So very important dashboard. So another really important set of service mesh dashboards is the service health dashboard. Each namespace or each application has got its own service health dashboard. This one here, as an example, is for search one read. As well as a number of stats at the top, you can see the list of applications that can talk into search one read. And I can see that search one read talks out to search solar. So quite a lot of apps talking to it, and it's only talking to one. Scrolling down, there's a wealth of information. So data around response codes, response times, destination response codes, and response times, which is really important in trying to investigate and identify where the root cause of an issue is. Scrolling down further, I've got some golden signals. So I can see the performance of all the apps that are talking into this app. And lots more information. This one's really good. So we got the CPU and RAM data, network and disk data, but we need to keep an eye on the CPU and RAM. So if we see any issues, we can up that for the application. So a wealth of information there. So next thing I want to show is Skipper. So Skipper is one of our alerting frameworks. What it does is takes alerts from Prometheus into Skipper, makes them a bit better, and then pushes these out into Slack. And via various configs, we can push the alerts into various Slack channels. So the main channel alerts we go into is this K8 Alerts Prod channel. So this is in Slack. I've just hidden the stuff on the left. I don't really want to show names or other channels, but this is important information here. And there's various alerts. So focus on some of these. So top one here, I briefly mentioned that this check's done against service owners. So here for advertising and branding, the service owner is invalid, and we get alert, and the information RAM alert is here. It's basically saying the owner cannot be located in the Active Directory user or groups. So Dylan has took this alert, and he's going to be speaking to a squad and getting the new squad owner. Just scrolling down, some more alerts here. So platform dashboard, application instance restarted. So we can see here that it's fired on these containers, and Carl's took ownership of this. Scrolling a bit further, platform dashboard, service returning a high amount of 500 codes. So again, it explains what the alert is. You've got the pod that's firing that alert. But I want to highlight this. So Carl's took ownership, and there's two replies here. So scroll down on here. So Skipper recognizes there's been a deployment. So some of the times when an issue occurs, it's due to a deployment. It's quite good having information straight away. I've shown 2 or 3 different places where we can see the deployment has recently occurred, but it's quite good to actually get it within the alert. So I've got alert. I can see that within the last 30 minutes, Skipper's telling me deployment has gone through and links through to Git and Go CD to get more information. And then secondly, this is more common, we get this information if there is an alert. Jaeger, there's 8 errors in Jaeger. So I can click on this link and go through to Jaeger and try and trace through where the issue is. So that's Skipper alerting. Okay, so fault injection. If you're running a lot of microservices, at some point an application will have issues. It's really crucial to understand what impact that has on connected applications. So that would be by trying to test with either increasing the latency or increasing the 500s or stuff like that. So we've done it, we've built out fault injection, and we can test this. So I'm going to use the our platform dashboard to show you how we would do that. So connect to the platform dashboard, and I'm on the app for search one read. Scroll down a bit, you can see the fault injection section. So I can inject latency a percentage of the time. I can inject status codes, and then as simple as applying the fault. So if I do this now, so pretend inject some latency a percentage of the time and click apply faults. I show you want to configure fault injection. Yes, I do. That's been configured. Good glow around here. That's an indication that a fault injection is on. To stop that, it's as simple as resetting default. That's gone. So I'll just show you what it looks like. So going on the search mesh, this is for Sauron Web. And Sauron Web connects to Search One Read. This is the app I did the fault injection on. I'll scroll down. So I have already done some tests. Done two tests. One injected latency, so increased response time. And you can see the increased response time on the app connecting to the app that did a fault injection. But the important bit is the impact from that. I can see at the same time as that, the 200s dropped off, meaning that this app doesn't like the latency on the app it's trying to connect to. That's one thing I've done. Also did a test increasing in 500. So increase in 500, and I can see the increase in 500 here, but no drop off in overall traffic. So it's more tolerant of a percentage of 500 within the app it's connecting to. Previously, it might have been this app might have completely keeled over if it hit a few 500s. So that's fault injection, a very clear and easy way of injecting, and a very clear, easy way of seeing the impact from that. As a company, we started introducing Chaos Fridays, so spending about an hour doing these fault injection tests, analysing the impact, making relevant changes to ensure the impact's minimised, and then testing again to confirm it works pretty well. So finally, just want to briefly talk about Chaos Kraken. Chaos Kraken is an application that we've recently open sourced. What it is, and it says it here, it's based on an application to simulate JVM-based failure scenarios when running on a delivery platform. This app actually created a number of years ago. It's back in 2017. It was built whilst we still had a private cloud, and we utilised or needed some app to test failure scenarios, so our operations people, staff, could learn a bit on how to react against those, or how to fix the issues they were coming across. But it was a really good tool back then to get us into more thinking cloud native. This is in github.com. Anyone can access this. Feel free to have a play. If you contributed, that would be awesome. And that's it. So I've been through quite a lot. Hopefully they'll take a few things away from it. Basically, I was just trying to show what a company our size, around 350 microservices, how we operate utilizing Kubernetes and Istio, and hopefully take some inspiration from that. So lastly, I've really enjoyed taking part in this virtual conference. Hopefully enjoy all the other presentations that are on, and speak to you in the future. Cheers.